Welcome to our segment on transformations in a modular MLOps pipeline. Transformations in a modular MLOps pipeline sets the stage by highlighting how each transformation sits in its own Python script paired with a type data class configuration. These pairs are referenced directly in DVC YAML, making it easier to maintain, test, and rerun only the parts that change. Slide number 2, Design Overview breaks down this structure. For every transformation, we rely on a dedicated Python file and a clearly typed config. This design prevents a sprawling code base and keeps all parameters in one place, clarifying allowable values. Slide number 3, Benefits, showcases how DVC partial reruns save time by rebuilding only the changed stage, such as mean_profit.yaml. Type parameters reduce confusion and ensure consistent data types. This partial rerun capability safeguards reproducibility and avoids unnecessary computation across the entire pipeline. Slide number 4, Workflow integration, connects the dots by illustrating how small parameter updates trigger only the relevant transformations, preserving both efficiency and reproducibility. The pipeline diagram helps visualize how scripts, YAML files, and data versions line up to maintain a clear, maintainable process. Well, I'm always striving to minimize the time to value for my clients. That means I want to enable them to quickly understand the structure of my solution and how to use it, how to extend it, how to work with it, showing that it's reproducible, it's dry, don't repeat yourself, and that it follows clear architectural choices and naming conventions. Now let's look at one such example. Transformation mean profit. We use this base name to define the core transformation function, the associated data class, the Python module that includes these two, and the Hydra, the YAML config here. We're using structured config so that universal step, which can process all of our steps are processed by this single function, making it truly universal and easier for the client to work with it. So here we can see that our structured config will cause the transformation to fail early if there are any mismatches between the YAML, the parameters defined in the YAML file and the structure and the data class for it. And like this, we have a consistent way of executing each stage in the pipeline, and we version it using Git and DVC. It's fully versioned every single time a transformation is run. This enables my clients to get value out of my solutions, usually within a month. I work with them afterwards. I take care that they understand things. I thoroughly document my solutions, and I feel that it's the way to move forward using modern MLOps principles and tools that we have. This is the way to go. The following example shows how a typical workflow using DVC repro looks like. Only rerun stages that have been modified or that depend on a stage that has been modified. To illustrate this, we're examining DVC YAML, specifically focusing on the yearly discharge bin stage. We can see it right here where the cursor is. And if we go to the associated YAML file, the config, we can see that the number of bins is set at 5. When the num_bins parameter is set to 5 in pandas qcut, the data is split into the 0th, 20th, 40th, 60th, and 80th, and 100th quantiles. So we plan to change this to 20. So with 20 bins in pandas qcut, basically we're looking at 5% increments, and we have two methods of doing this. So the first method is adding an explicit override here to the cmd command, or we can change it in the YAML file, which we will do in this case. All right, then let's look at the stage, and currently we have it set to number of bins 5. Now let's change that to 20, and let's see what that means. So if we go for DVC repro, we go for a dry run like this, we can see it even more clear, and we can see that there are changes. However, because the stage is cached with the current changes, it's not being rerun. So if we do run it, let's do it. DVC repro, DVC. So this is updating the data version 10. And we are going to run our examples here, and we're going to look at the number of unique values for the for the yearly discharge bin. So we get 20. That's exactly what we did here. So that's updated. And if we go for DVC status, all pipelines are up to date. That's great for us. And now if we want to go back, we can basically we run DVC repro. Again, it's cached. And we go for status, all up to date. And we can check it now here. And we're back to number of bins 5. That's how easy it is. This video offers insights into how an effectively managed DVC YAML transforms a complex set of ML tasks into a clean, maintainable workflow.